And now looking at 18.6, we're talking about practical graphs. Okay, so this is your Coursebook 9. Let's look at number 1. A tree is 6 meters high, grows 0.5 meters each year. So now you need to write down a formula to show the height y in meters as a function of time x in years. So now we need to figure out what is the relationship between the height and years. So as the years goes by, it increases 0.5 every single year. So I can tell that the formula can look like this. The height of the tree is equal to 6 because this is the current height plus 0.5 multiplied by how many years that have gone by, which is x. So this one right here is a multiplication. So let's try to draw a graph to show the formula. So the first one will be 6. So let's just write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number of years will be written here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years. So this is the height. So 0 here, and then we start. 6 years in the beginning. Sorry, do not draw your origin, draw just here. This is the beginning. And every 2 years, it increased by 1. So that's what I'm going to do. Every 2 years, it becomes 6, becomes 7, 7 becomes 8, 8 becomes 9, 9 becomes 10. So just draw a line like that, and then put it back. So now it says that use the graph to find the height of the tree after 5 years. So now we need to go 5 years from here, go up. What is the height from here? You can see the height is right in the middle of 8 and 9, so the answer would be 8.5 meters. When they say use the graph, you must show this because this is what you call your working. And then the next one, they ask you the number of years until the tree is 10 meters high. So 10 meters high means that we need to go from the height. Starting from the height, we move 10 meters all the way here. And then we move downwards to show them. It takes 8 years. All right, so this is bigger. Let's look at number 2. A candle is 30 centimeters long, burns down 2 centimeters every hour. Write down a formula to show the height in centimeters as a function of time in hours. So now we need to show this is a reduction, so it's a negative gradient. So a candle is already 30 centimeters long. It burns down 2 centimeters every hour. So the formula, I would actually say that the height is equal to 30 minus, depending on how many hours, 2 multiplied by the hours, which is time. So h is equals to 30 minus 2t. Draw a graph to show the height of the candle. Well, sure. Let's just try to do it. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's try to do it like that. And in the beginning, it will be at 30. So every hour, it dropped by 2. So I'll just take the extreme, which is after 10 hours, the height will be at 10 centimeters. Because 30 minus 20 is equal to 10. Now we need to draw a line here from here, straight up to here. This is how you can estimate your graph, just by taking 2 points. Like just now, we try to do it every other 2 points, but in reality, you only need to identify 2 coordinates, then you should be able to get your answers. Okay, so this is your graph, done. Use the graph to find the height of the candle after 4 hours. So use your graph, 4 hours, go to number 4, move your way up. From here, you should be able to maneuver it a little bit. Here. So well, you can actually estimate it, but you can calculate it using the formula itself. After 4 hours, it should be about 22. The last one, the time until the candle is half its original length. So half the original length, which is 15. So let's try go 15 right here. How long it takes? It looks like it's between 7 and 8. I would say 7.5 hours. Once this is done, we need to look at number 3. The cost of a taxi is $5 for each kilometer. Write down a formula for the cost C in dollars in terms of the distance in kilometers. So this is direct. There is no initial or starting value. So 3A would be cost is equals to 5 multiplied by distance. That's it. So this one is a direct proportion whereby when one is 0, the other one is 0 as well. Draw the graph to show the cost. Okay, I'm just going to draw it here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is kilometers. And then my cost should be here. 5, 10, 15, 20, 25, 30, 35, 40, 45. So this is in dollars. Now, I just need to do it. Every 1 kilometer is 5, and then at 10 kilometers, it should be 50. There's no 50 here. Let's just do it at 9. So just draw a line from 0 until here. I can draw over it, no problem. This is for B. I can see, use the graph to find the cost of the journey at 6.5 kilometers. So C1. I should extend my graph because apparently the question requires it to be more. Let me just extend it slightly further. Question requires it to be up to 55. Just erase this. So 11 would be extending the graph just a wee bit. Yeah. So to show the cost of journey of 6.5 kilometers, 6.5 would be here. Which I would say is 32.5. And the second one, it says that at $55. So if you calculate mathematically, you should be able to know what's the answer, but they want you to use the graph. So you have to show in the graph so that you can tell the examiners that you understand what they're trying to say. So it will be 11 kilometers. Number 3, look at number 4. There are 6 cars in the car park. Every minute, another 2 cars enter the car park, no cars leave. So there are already 6 cars here. And every hour, every minute, 2 cars enter the car park. Every minute. Write down a formula to show the number of cars Y in the car park after 3 minutes. Y is equals to 6 cars plus 2 multiplied by the minutes, which is 2T. We can actually do show a formula out. Draw a graph to show the number of cars in the car park. So we can show, let's say 24. 24, 18, 06. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 24. 24 is a little bit big, so let me just draw it bigger then. So I look at the question because the question needs it to be up to 24. So I'm looking at here right now. So from here, we can just extend it because I need at least 12 to be until 24. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, oopsie, 24 weeks. And here I also need to extend a little bit more. It's not enough. 11, 12, 13, 14. So 0, there'll be 6 cars in the beginning. Every minute it increases by 2. So let's just draw it. Let's just say every 1 minute increase by 2. So in the first minute it'll be 8. And then that's it. Let's just draw a graph past that point. The number of cars after 5 minutes. 5 minutes. Answer should be 16. The time before there are 24 cars in the car park. So 24 cars is here. We just need to extend it down. 9 minutes. The car park only has spaces for 24 cars. Show that in this graph. So just remove this up. Means that we cannot have anything more than 24. This is the maximum. So it means after 24, you shouldn't be drawing anymore. Okay, and that's it. Now let's look at number 5. Anders has 20 credit on a mobile phone. Each tax costs 50 cents. Write down the formula for the credit. C in dollar after sending P taxes. Text. The 5A should be C is equals to P minus. So every tax is cents, you minus 50 cents. Draw a graph to show the credit. Okay, so I need up to 11. Oh my God. Up to 11. So this one has to increase by 1. So 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. Up to you what you want to do. You want to do 2, 4, 6, 8, 10, also can. But if you want to do 5, 10, 15, also can. It's up to you. The number of tax 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I put up to 11 because I saw the question here. Okay, so now you need to draw the graph, which is this one here. Starts with a credit of 20. So every tax costs 50 cents. So I don't like that decimal places. So every 2 tax costs $1. Every 10 tax costs $5. So I'm just going to take this right here. Every 10 tax costs $5. So after 10 tax, you'll be here. So this is how my graph will look like. And I say, oh, Anders sends 11 tax. How much credit is left? Okay, it didn't say that you need to use the graph. So I would just use calculation method to show it to you. So C, it says that 11 tax. So there should be, the credit will be 20 minus 11 times 0.5. Or you just want to write 0.5 times 11, also can. C is equal to 20 minus $5.50, $14.50. That's how you do number 5. Then we go to number 6. Population of an animal in the wildlife reserve is 8,000. Population decreases 500 each year. Write down a formula to show the population as a function of a number of years. 8,000 minus 500 per year. That's it. Draw a graph. So remember to label your graph. I always forget to do that. Population, and then this is here. So let's see. Oh, we need until half. Half means what? Okay, 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the population here, probably put 100, 200, no, 1,000, sorry. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. So start with 8,000 in the beginning. Every 2 years, drop by 1,000. That's it. Use the graph to find the population after 4 years. $6,000. See? So I can just write C is equal to 1,000. How long will it be until the population is half? Half would be 4,000. So now we go to 4,000 and try to track it down. How many years? 8 years. Okay, now last 2 questions, 7 and 8. This graph shows the predicted population of a country. What is the population now? So this is 10 years from now. What is the population as you can see from the graph? Okay, this is the graph that we're talking about. This is for number 7. So let me just draw a line just to split it. Okay, this is number 7. Population now is here. So what is the population now? 12 million. Next one, find out the estimated population in 30 years' time. So they gave you a graph. So in 30 years' time, we need to just backtrack it. 30 years right here. We go really straight right here. It's right in the middle of 16 and 14. So I'm just going to say 15 million. Work out the gradient of the graph. Well, gradient of the graph, we can just use it. So I'll just pick 2 points. I like the points here and here. So the point here will be 0, 12. The other point here will be 20, 14. Like I said, find the gradient. Just use y2 minus y1, x2 minus x1. So 0, 12 and 20, 14. Do not put your x at the top, okay? So your gradient will be, just take the first one, 12 minus 14 over 0 minus 20. You get -2 over -20, which is 1 over 10. Because negative and negative, when you divide it, it becomes positive. So that's the gradient. Now, find a formula for P as a function of T. So you can see every 30 years, it increased by 3 million. So 10 years should be 1 million. So 3 years, 3 million. 1 year, 1 million. On estimate. So I can just say that the formula of population is equals to 12 million plus 1 million every year. So I just write 1 million per year. Like that. This is your formula. T is a function of T, so not year. T is a year. And the last one, Sasha put 2,000 in the bank pays her $50 every year. Work out a formula for the amount she has in dollars after T years. So I probably need to crop this out. So I can't see it on the other side. Let's take this out. Just place it right here. Formula for the amount she has after T years. So I'm just going to write down the formula. A is equals to 2,000 plus $50 every year. So if they say the year is T, then just put T. If the year is Y, then just put Y. It's up to the question, really. Draw a graph to show how the money increases. Okay, 2,600. So let's just put 2,600. So what multiples can I use here? 100 is too small. 200. Okay, I'm just going to bring this down so that I can increase this. So 200, 200, 200. I just need 13 blocks. So that's how I get how I draw my graph. Okay, so I need 13 blocks to be up to here. So 200, 400, 600, 800, 1,000, 1,200, 1,400, 14, 16, 18, 2,000, 2,200, 2,400. There we go, 2,600. That's how I determine what my range is. Okay, so 0 here, the number of years will be here. Normally the years will be at the bottom. These years. Don't know whether 10 years is enough. Probably enough. 10 years I get $500. So probably yes. So I'll start at 2,000. That's the first year. And then the bank pays 50 every year. So I would think that, oh yeah, every 2 years I get, but every 4 years I'll get 200. Because the next one is increased by 200. So I'll just use that in mind. So I just want to find how long it takes to increase 200. 1 year, 50. So 4 years, 200. So I'll just put 4 here and then put here. I'll just draw a line. There we go. That's the graph that we need to draw. How much does she have after 5 years? So never tell you to use your graph, huh? Never tell you to use your graph. I would just calculate because they didn't say use your graph. So I'll just think that, oh, 5 years, I'll just use the formula. A is equals to 2,000 plus 50, 5 years. Right? Great. And then last one, how long does it take until she has 2,006? Okay, I can use the graph. I just show you how I use the graph. So 2,600, I circle it. I circle it here. So it's relatively hard to say. So you can come down 600 should be 13 years. Yeah, should be 13 years. Yeah. Or 12 years. Yeah, 12 years. Okay, so if I extend my graph right here, I should get 12 years. Let me just extend it just to show it to you. But what if I don't want to use the graph? I need to use my formula. So if I use my formula, what is saying that A is actually equals to 2,600. It became 2,600. So I need to reverse and find out what my T is. So what is my T? So I just take 2,600 is equals to 2,000 plus 50 T. So I just can minus out 50 T is equals to 2,600 minus 2,000 is 600 T. T is equal to 600 divided by 50. T is equal to 12. Yes. Calculation also can, graphing method also can. Up to you.